So, Assalamualaikum once again. So, this is the second video for lecture notes number 5, okay? So again, in the first video, we have talked about the concept, or I have introduced to you what is trust in engineering, okay? Ano ba yung sinasabing trust sa engineering? But this time in this video, ang pag-uusapan natin ay yung method of joints. Yun nga yung sabi ko sa first video natin. To analyze trust, we have these two methods to use. Okay, first is the method of joints, and second is the method of sections. This time in this video, we will be talking about method of joints, how to analyze a truss using method of joints. Okay, so keep updated. So in method of joints, to find the forces in the members of a truss consists of satisfying the conditions of equilibrium for the forces acting on the connecting pin of each joint. Okay, so first things first, let's consider this simple truss. Okay, okay, this is point A, B, C, D, E, and F. To analyze a truss, as much as you can, please put an indication or point by point, lagyan ninyo ng indication na this is point A, B, C, D, E, and F for you to avoid, or for us to avoid this confusion, okay? So for example, this is point A, this is point B, C, D, E, and F, okay? These are the points of the truss, okay? So, yung point sa truss ay yan yung tinatawag nating joint. Gets? Yan yung tinatawag nating joint in which doon nakakonect or doon connected yung lahat ng members or yung some parts of the truss or some members of the truss. So, sa first statement na ito, dapat daw masatisfy yung conditions of equilibrium. Dapat masatisfy yung summation of all forces along X, all forces along Y, and all forces or all summation of moment equals to 0 in each joint. Gets ba yun? So, dapat acting on the connecting pin of each joint. Okay? Connecting pin of each joint. So, next is we begin the analysis. Okay? Next is we begin the analysis with any point where at least one known load exists and where not more than two unknown forces are present. So, ito yung ibig sabihin dyan, class. Ang sabi dito, summation of all forces at X equals to 0. Summation of all forces along Y is equal to 0. And summation of moment equals to 0. Yan yung three sources of our equation. Yan yung equilibrium. Sa second statement, ito, as you can see, di ba? If we are to draw the free body diagram, as you can see, this is hinge. Yung sabi natin sa hinge is may dalawang forces along X and along Y. Remember? Sa fourth lecture natin. At saka itong dito, itong sa point E, may support dito na roller, okay? So we assume that this is AY and this is AX. This is EY, okay? So sa second statement, we begin the analysis with any joint. Meaning to say, magsisimula yung analysis natin sa kahit saang joint dyan where at least one known load. Meaning to say, magsisimula yung analysis natin sa isang joint na kung saan may at least isang known or at least may isang given na load. At saka, dapat yung unknown ay hindi lalagpas ng dalawa, okay? Yung unknown forces ay hindi lalagpas ng dalawa. For example, we assume that in point A sa joint A, okay? This is joint A. So may members dito, as you can see. Tapos yung forces na AY at saka yung AX. So sa pag-analyze is dapat sa joint na ito ay may isang at least na nabigay na nabigay na load. Let's say ito, given ito na 1 kilonewton. So satisfied. Pero make sure na yung unknown ay hindi lalagpas ng what? Make sure yung unknown ay hindi lalagpas ng dalawa. So, if we are to see this one, for example, this is force AB, and this is force AF. Tapos, ito is i-breakdown natin sa components nito in which F, ABX, and F, A, B, Y. So, kung titingnan natin, ito, okay, sabihin natin na hanap natin yung value nito na 1 kilonewton din, okay? Kung titingnan natin, tatlo yung unknown dito. Or hindi tatlo, dalawa lang kasi it just happen na may components dito na X and Y. So, kung titingnan natin, ito is na-satisfy nito yung condition na may nabigay na load at least one. Ito, at least one. Ito, this case, dalawa yung nakuha nating loads. Tapos, with not more than two unknown forces. This time, yung unknown lang is yung FAB at saka yung FAF. So, meaning to say, kung magsisimula tayo sa pag-analyze using point A, it is okay. Since may nabigay na at least 1, at saka yung unknown ay hindi lumagpas ng dalawa. Okay? That is how we should start analyzing the method of joints. So, let's consider this, or to give you the clearer view, let's consider this figure number 5, okay? This figure number 5. Example, this simple truss, this given simple truss. Sa pag-analyze ng truss, the bigger the picture is the better, okay? Meaning to say, kung mas malaki yung figure ninyo, mas mabuti para mas maging klaro yung pagsusolve ninyo. This is actually a ruler. So, this is yung isign natin yung mga point A, B, C, D, E, and F, okay? Ito yung joints natin, si joint A, B, C, so on and so forth. Ito yung simple truss. Tapos, may assigned load dito na point B. May assigned load dito na L. Okay? So, kung ito-draw natin yung FBD, ito yung simple truss. Kung ito-draw natin yung FBD, okay, let's just use this Gamitin lang natin yung figure na ito. Kung ito-draw natin yung FBD, ito is my reaction dito along X, along Y, at saka may reaction dito along X. Okay? This is AX. Let's use the letters to denote that this is a force in A, at saka this is a force in D. So, DY. Okay? So, ito yung FBD. Kanina yung nung wala pa yung forces na ito, tawag doon is yung original or yung actual diagram. This time, since na-draw natin or sinulat natin yung reactions, meaning to say, yan yung free body diagram. Okay? So, ganito klase yung pag-analyze ng truss using method of joints. Sa pag-a-analyze ng truss using method of joints, dapat is titingnan natin is yung joint, okay? Titingnan natin yung joint in which dapat may bigay or may known or may binigay na at least isang load. At saka dapat yung unknown ay hindi lalagpas ng dalawa. Let's say itong point A, okay? Si point A. Kapag nag-analyze kayo ng joint, i-concentrate lang natin yung focus natin. Dapat concentrated yung focus natin sa joint na yun alone. Okay? For example, at joint A. Okay? At joint A. So, as you can see, sa joint A, may members na AF at saka may members na AB. Gets? This is AF and this is AB. So, dyan is my force tayo na AY at saka AX. Okay? As you can see, may load dito sa point B na L. Pero, kung i-analyze natin yung joint A, itong joint A, hindi ma-include or hindi masasali yung load na L. Okay? Ito lang mismo. Itong dito. So, this is point A. As you can see, kung i-assume natin, kung titingnan natin, itong AX ay papunta sa right? So, meaning to say, kung titingnan natin yung itong FBD natin, yung X lang or yung forces along X lang ay AX, right? Kung since yan lang yung force natin, pwede natin sabihin na this one is actually equal to 0. So, meaning to say, ito is pwede natin erase since for running purpose because kung consider natin yung actual or yung FBD natin, yung value ng AX is 0. So, pwede na natin i-erase dito. So, next, let's say may nakuha tayong isang load na AY. So, ito, nakuha na natin to. Example lang nga, may nakuha tayong AY. Next is tingnan natin yung mga internal forces. Assume natin na itong si AB, itong force AB is along sa right, meaning to say tension. This is force AB. If ito is along right, sabihin natin na itong force AF ay ganito yung direction. Bakit? AB at si AF. Bakit sinabi natin ganito yung direction? Tingnan natin kung i-breakdown natin yung components ng AF into X and Y. 'Di ba? Komponente na giya AFY and AFX. Kung titingnan natin, may equilibrium so joint A tano kasi ng AY pataas tapos AFY is pababa. AB natin is papuntang right tapos AFX natin is papuntang left. Kung isusulat natin, okay? Kung isusulat natin yung equilibrium or equilibrium equations, summation of all forces at x equals to 0, si AB natin minus AFX equals to 0. So, AB is equal to AFX, equilibrium. Tapos, FY equals to 0. My AY or my AY minus AFY, equilibrium, okay? AY is equal to AFY. So, as you can see, masasabi nating equilibrium yung isang bagay kapag nag-equal yung dalawang forces. Along X, AB at AFX equal. AY at saka AFY equal. Meaning to say, okay. Meaning to say, equilibrium. Example, kapag itong AFX is naging negative, meaning to say, hindi equilibrium. Dapat equivalent yung dalawang yan para masasabi natin rigid or hindi nag-move yung isang structure natin. So, tingnan natin. Nung i-consider natin yung joint A, may given loading tayo na AY. Okay. So, na-check yung first condition. Second condition, dapat daw ay hindi lalagpas ng dalawang unknown yung joint na yun. Kung titingnan natin, yung unknown dito ay AB at saka AF lang. So, meaning to say, okay. So, it is okay, it is fine to start your analysis sa joint A. Gets yun? So, yun yung ibig sabihin sa statement kanina. Kung titingnan natin, diba? Kung titingnan natin, ito yung joint A, right? Ito yung joint A. Tapos, at ayun yung reactions na ito. Ito yung reactions na AY. Ito yung AB. Tingnan natin, si AB is tension. Okay, i-neglect natin na yung figure na sa taas. Kung titingnan natin, okay. Kung titingnan natin, si AB is tension. Tapos, si AF ay compression. Tension siya kapag away from the joint. Tapos, compression siya kapag towards the joint. Ganito yung concept. Example, this is the joint. Tension siya kapag away. Okay? This is away from the joint. Tapos kapag towards the joint, this is AF. This is compression. Again, tension to kapag palayo or lumalayo sa joint. Pero compression kapag it is going towards the joint. See the difference? So, ganun yung ibig sabihin sa compression at tension. If you want to furtherly see kung ano yung ibang analysis ng ibang joints, you can see for this figure number 6. Okay? Okay, another thing before tayo mag-continue sa kabilang, sa first problem natin. Same truss, okay? Okay, let's consider the same truss with a given loading L dito, may L dito, tapos nandito yung AY. Wala na yung AX kasi kasi 0 lang yun dahil wala na ibang components along X. Tapos ito si DY. Kung titingnan natin yung at joint A, di ba? Kung titingnan natin sa joint A, nandito. Tapos sa joint A na yan is meron tayong AY. Okay? So may AY tayo, tapos yung kanina, yung na-solve natin kanina, yung show natin kanina, ito yung AB at saka ito yung AF. Okay? So, kung mag-next step tayo ng analysis, let's say for example, dito sa point F, sabihin natin ito yung point F at joint F. If we are to consider the joint F, ito, joint F, di ba ganito yung F? Kung i-consider natin class yung joint F, ito siya. Itong F dito. Ito. Dapat is uniform pa rin yung pag-analyze natin, or kumbaga na uniform yung application or uniform yung effect ng loading sa every member. Example, this is joint A, di ba? Ito yung joint A, tapos ito yung joint F. As you can see, di ba joint A, joint F, katayas ka niyan? Di ba AF saya na compression, right? AF is compression. Kung i-analyze din natin yung joint F, yung member AF din is dapat compression. Gets ba yun? This is compression. AF. Kung sa joint A, yung AF is compression, dapat sa joint F din is dapat yung AF din is compression. Gets ba yun? Consider natin yung joint B. Kung sa joint B, kung sa joint B tayo, at joint B, ito si joint B, ito si B. Kung titingnan natin dito, kung titingnan natin sa joint A, di ba? Sa joint A na si AB na tension, dapat din sa joint B, yung force AB natin is tension. Gets? So, yan yung pag-analyze. Dapat continuous. Kung yung dito is tension, dapat yung analysis din natin dito is tension. Ganito yung magiging itsura. Okay? Compression dito. Kung tension, di ba? Tension na yan. Then, tension din dito sa kabila. Kung compression dito, dapat compression din dito. Okay? So, ganun. So, this is all for the introduction of method of joints. Next video is yung example. First example ng method of sections.